Seeing as there are already many websites and videos showing how superheterodyne radios work, one might question what is the point in producing yet another one. What we're going to do this time is we're going to take a more practical approach to understanding how a superhet works. We take a quick look at this diagram. This is the one we see just about everywhere, including in many textbooks explaining the basics of how a superhet works. The blocks are simple but not necessarily easy to understand. We have the signal coming in from the left. This is the radio signal. It goes into a mixer. There is an oscillator which feeds into the mixer. The resultant frequency comes out, goes into the intermediate frequency stage, which is the IF amplifiers. It then goes through a detector, and then from there to the audio frequency stages. That's about as far as it goes. Obviously one can go a little bit further to explaining what each block does, but I think personally it's much easier to take a more practical approach. So let's have a look at a circuit diagram from a relatively old superhet, but it's nicely laid out and easy to understand. This particular picture is from the May 1966 Practical Wireless. Here are the stages, but instead of blocks we see them as transistors. These are transistors, as we know. There are in fact 6 in total. 1, 2, 3, 4, 5, 6, and a diode. Let's follow the stages as we saw in the block diagram. Here is the aerial, which is the ferrite aerial in the case of this radio. There's a tuning capacitor across the radio, so that tunes the aerial circuit. This is fed into this first transistor. This is the oscillator mixer transistor. This actually does 2 jobs. It oscillates and it mixes the signal with the resulting oscillation. It then posts this out the top at a specific frequency, which is usually around 465 kilohertz, and it goes into the IF stages. It's coupled to the base of the next transistor, which then amplifies it again, goes through a second IFT, intermediate frequency transformer, and it's at the same frequency again, 465k, and it feeds to the last stage, which amplifies it again. So you actually have 2 IF amplifiers here. IFT3, then the output of that goes through the diode for detecting or demodulation, if you like, into the volume control, then off to the 3 transistors that are the amplifier. Okay, so it's the same again as we've just said with the transistors. Look at it from left to right. We have oscillator mixer, IF stages, detector, and first audio amp, second audio amp, loudspeaker. Let's go through that again. Now this is an interesting valve here because unlike this one and these two, there are actually 2 valves in the envelope. What that means is, this is actually strictly speaking not true. There is actually another grid put in there. There are 5 grids in this half of the valve, call it this end of the valve. On this side there is a triode valve. So you have 2 valves in the same glass envelope. What you do is you have the signal coming in here on the left, exactly the same as it was with the ferrite aerial, but of course this isn't a ferrite aerial, this needs a separate aerial itself. That feeds into the control grid in the first valve. Now this half of the valve is oscillating away like our transistor was. It oscillates at a specific oscillating frequency to give us a resultant at the IF stage here, which would be 465 or whatever, 465 kilohertz. It goes through. In this circuit we only have 1 IF amplifier, because then once it goes through the second one, this is tuned to 465 kilohertz, it comes out and it goes into here. This is a double diode triode, it is called. And what that is it's a triode valve, one with 3 electrodes, grid, anode and cathode, a filament, and it has 2 diodes built in. So what we're doing is we're feeding the modulated 465 kilohertz signal into one of those diodes. So if we look on the anode here, we find that audio comes out. So the audio then is fed into the output valve and from there to the speaker. Remember the automatic frequency control, automatic volume control, there's the AVC line there running through again like it was with the transistor set. Note how similar it is, the layout, to the transistor set. Now the reason why I'm mentioning this particular one, this particular circuit we adapted for use in our HECL NAFI radio set that uses a very similar circuit to this, but we adapted the front end and changed the back end a little bit. So if we move that out of the way, let's look at another version. So remember, this is a triode heptode. One grid that normally has 5. It doesn't show the 5th one in that picture. This from Practical Wireless, February 1960. This is yet another way of doing the same thing. So let's zoom in on that one. This is different again. Why? It's still valves. It still has an aerial coil, still has an aerial, but unlike the double valve and the transistor, we have 2 separate valves for the oscillator and the mixer. So the aerial signal goes into this pentode and it goes through the pentode, but there is an oscillator here with an oscillator coil, and it's feeding through into the suppressor grid. And that means that the signal going through from the aerial will be modulated at the frequency of that valve, which means, once again, introduced to the IFT in the anode is 460, 465, 470, whatever the IF frequency is of the set. Same with the previous one. We just have one valve as an IF amp. Goes through the second IFT, comes out and goes straight in, and it's turned into audio via this one here, this first audio and detector. That then feeds through the capacitor into the output stage. So there we go. That's giving some idea of the differences which there are. So this is more unusual, having separate valves, but somebody I think is trying to make a point because they're using 5 identical valves for this. They're using all of them are 6K7s, which is an interesting approach, I guess. So the last one is the one which I think we'll be following today for our little experiment here. This is, there we go, this in fact is a battery valve set. Battery valve sets came out like this in the 50s to give portable sets so people can walk around with them. They were relatively short-lived, shall we say, because transistors were going to come in the middle of the 50s, and by the end of the 50s there were transistor sets on the market. So one of the principal reasons why these were not a great success against transistors, apart from the fact they are much more bulky and bigger, is the fact that the batteries are so expensive. So of course there were several which were battery mains, and they carried on for many more years after that because people could leave them plugged into the mains and they worked just fine. But let's looking at the circuit. You've seen a few superhets now we've been looking at. You can probably see the similar sort of layout as there are in the other superhets. On the left we have an oscillator mixer, IF amplifier, detector, first audio, and the output stage. Now straight away you see there's something different about this, because instead of having either 2 valves in the same case or 2 separate valves for the mixer and the oscillator, this one does the job of both. This is actually a heptode, and it has a total of 5 grids in it, and they split up the valve basically to use one of the grids as an anode. And here we have the oscillator coil. So this portion of the valve works as an oscillator on its own, and it doesn't care what goes on at this end. Then if you feed the signal in through here, through the 3rd grid in this particular circuit, sometimes it's the 2nd, then that will be mixed with the oscillator. The output will be 465, 470 or whatever in the IF. IF passes this through, that's modulated obviously by the signal coming through, goes into the 2nd valve. This is our only IF amplifier, it's amplifying that frequency through the IF transformer, 465, 470 kilohertz, comes out the other end, fed into the diode of the diode pentode, note the diode at the bottom. Then once it's gone through the diode, it's been rectified, and we come out the other end and we can feed it to the output stage as an audio frequency signal. Now what we're going to do is we're going to look at this circuit actually on the radio working, because we have one of these, and a bit of nostalgia. It's a 1950s set and it works very nicely, but the HT battery is made up of a lot of PP3s, or 9 volts, but it still works great. And likewise you can see how it works. Now we're going to do our description of how it works back to front. A lot of people usually start at the front, we're going to start at the back. By doing so, we will show you on a working set the output stage. We'll go back, we'll look at the driver for the output, which is just after the diode. We'll then look at the output of the first IF, and you'll be able to see the modulated 47465 kilohertz signal. And then at that point we'll stop, because what we've done then is we've actually built this separately. We built a separate circuit on our universal chassis we've used for all our other projects. We built this portion here, and we will show you that this valve on its own actually oscillating on its own. Then we will pop an IF in here, put a tuning capacitor and a coil across here, connected aerial to that, and we'll see if we can actually make it work like a proper radio picking up signals. Here we have a Sky Baronet. Don't you just love that name? This is a 1950s battery valve radio. It's a portable one. Yep, you can take it around and listen to it on the beach or wherever you shouldn't be listening to it. This is in common to several. There's a way of opening up this particular one. You have the 3 knobs on it with your medium wave, long wave, and volume control and a tuning control. Does it work? Of course it works. So if we pick radio 2, beg your pardon, radio 4 long wave, we turn it on.
Maybe a long-term change, but when you see Bitcoin advertised, something is going on. There are a lot of young people,
there we go,
anecdotally mostly men, who think it is fun or profitable, and we need to hear from them.
Right, there we go. That's it working. So what we're going to do now is we're going to open up the back, and we're going to look at those particular places on the circuit diagram, and we'll explain what we're looking at. Here we have the inside of the Sky Baronet. Just ignore all the batteries cobbled together there to give it enough power to work. We have the oscilloscope here. The probe is connected, the earth is to the tuning capacitor metalwork, because that's the best earth I can find around there. Only going to look at 2 places here, but hopefully this should make everything quite clear. Remember, in this we have 2 valves doing the audio. The second one, of course, sorry, the first one here is the diode as well. So if we'll have a look at the output of this valve here, this is pin 5, which is the anode of the driver, with the audio driver. So if I put that on, we'll have a look at the scope. We have radio 4 on, so that I think comes out over there. And there we go. I kept the volume turned down, but you can hear that's the speech. So that is the output of the driver valve. Now we won't look at what's going in here with the diode, but instead we'll look at the output of the IF amplifier. Remember, there's only one IF amplifier here, oscillator mixer IF amplifier. So we look at pin 2 of that one. That actually comes out on this IFT up here. And that is the IF we're looking at. That's all we do on this circuit here, but those are the bits, remember. So we've seen the audio, we've seen it's detected, you lose the 465 kilohertz. There's the IF amplifier. So what we're going to do now is we're going to move the whole setup around. We've built this on our chassis, so we'll be able to show the amplifier working, sorry, the oscillator working, and then eventually it mixing it. And our final thing, which we hope we'll do and hope it'll work, is we'll produce an audio signal of a radio wave going straight through the entire system, including our newly built set. I think before we move on from the Sky Baronet, it's worth looking at this little object here, and this shows how the industry changed in a few years. This being a 1950s set, transistors came along, and that is what people were buying in the early 1960s. This is a typical early 1960s set. Note, these are the IF coils, these are the IF coils in the valve set, these are the IF coils in the transistor set. This one's the oscillator coil, then you have the first, second and third IFs. Dual gang tuning capacitor, and everything's on a ferrite aerial. Nothing separate, no separate aerials at all. Everything goes in there. 2 transistors in the output stage, driver transformer, output transformer, and there were another 4 transistors, oscillator mixer, 2 IFs, and the driver. Does it work? It works. And this is what people were buying in the 1960s. So, one asked the question, why is it that they were unpopular in the 60s and they had a short life? Well, a bit different buying something as small as that. Let's move on.